Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are looking at electrochemistry, and we are still on the application of electrolysis. So today we are going to look at the purification. So we talked about electroplating before and we saw how electroplating occurs. So today we'll see how purification of metals occurs, and then we'll do some sample questions. So in this method of electrolysis, it's used to refine metals mostly, and you notice you're going to mention them later on also when we dig deeper into the extraction of metals. So metals like copper, zinc, tin, lead, silver, gold are usually refined by electrolysis method. So in an electrolytic cell, a block of an impure metal is made into the anode. So it is important you see where the anode is, especially with this method of application. And then a strip of a pure metal is placed as the cathode. And an electrolyte is made out of a suitable metal sort of the metal to be refined. So when an electric current is passed through the cell, ions from the anode enter the electrolyte, and the same number of metal ions from the electrolyte gets deposited on the cathode. And then some impurities usually remain in the electrolyte, and some of the impurities may be deposited below the anode. We usually call them, sometimes they are referred to as sludge or slag, but mostly they are the impurities. So an example is a setup shown as you can see on the anode. You place the copper, impure copper, and then there's pure copper on the cathode, and then we have the electrolyte as copper sulfate solution. That means it contains copper ions. So that's how the setup looks like, but now we're going to go to the details of samples of how we can purify some different compounds. So we'll start with the purification of gold. So gold is used as the anode. So the gold alloy, when you talk about alloys, is a mixture of other metals. So it's not a pure gold, while a thin sheet of pure gold is used as the cathode, and then the electrolyte used is hydrochloric acid. So let's do that. So we are going to show that using a diagram. So we have the impure gold or the gold alloy, and then the gold alloy is connected. It is on the anode, so the cathode is the pure gold strip, and then they have been put in a solution of hydrochloric acid. So this is gold. So the electrons will move from the gold anode. So this is the anode, and then this is the cathode. And it's going to move through the wires to the cathode, where there's a discharge that happens. So remember that at the anode now, we have the gold impurities. So gold goes into solution and is discharged to form gold ions. An electron is given off, which travels to the cathode. So when it goes to the cathode, remember this reaction has hydrochloric acid, but remember in the cathode we are giving off some gold ions in solution. So at the cathode, the gold ions that have gotten into the solution gain those electrons to form gold solid, which now is deposited on the pure electrode on the cathode. So that is what happens in this reaction. So basically the ions that are given from the anode are usually gains electrons again to be deposited at the cathode. So that's how the alloys form. The alloys is purified, and then you notice some deposits here of the other metals now that are given off because it was an alloy. It means it was impure. So we have the impurities at the bottom. So when you're drawing your diagram, you need to identify the solution, that electrolyte that is used. You need to identify the anode and the cathode and also the battery, and show also the flow of electrons when you're giving your answers. Let's do another example. Purification of silver alloy. So crude silver is used as the anode, while pure silver is used as the cathode, and in this process nitric bath is used as electrolyte. So let's show that in our setup. So we start by drawing the setup of the electrolysis. So they are both placed in a solution of nitric acid. So we need to show that. So we have the impure, the silver, and you notice that it's fully immersed in the solution. And then we have the pure silver. So the impure one is connected to a wire on the positive side of the battery, and then the pure one is connected on the negative side. So this is the anode. So we will indicate this is the crude silver. So you can show that crude silver, and then this is pure silver, and this is still the not the wire, the cathode. So electrons flow from the anode to the cathode through the wires. So on the anode, so silver is discharged in solution to give silver ions, and an electron is given off. This electron travels to the cathode. Remember, there are silver ions in solution. So at the cathode, the silver ions in solution gain those electrons to form silver solid. So that silver solid is the one that is deposited on the pure silver. So with time, you're going to notice some deposits at the bottom. We call them the sludge of the impure substances that were in the silver. So let's do another question. So we have the purification of zinc, and we're going to use crude zinc as the anode, and the pure strip of zinc used as a cathode, and the electrolysis is the zinc sulfate. So let's draw the setup together. So we have the impure zinc, that is the crude zinc, and then we have the pure one on the cathode. So this is connected to the cathode, the positive side using a wire. So the electrons definitely flow from the anode to the cathode. So this is the cathode, and it's the pure zinc, and then this is the anode, crude zinc, and then they have been placed in a solution of zinc sulfate. So if we were to write the equations that occur at the anode and the cathode, so at the anode, zinc is discharged to give zinc ions, and 2 electrons are given off. They travel to the cathode. So at the cathode, so zinc ions in solution gain those two electrons to form zinc solid, so which is deposited on top of the zinc, and then we have some impurities that are given off. So that brings us to the end. That's how purification occurs using electrolysis method. So in the next, we are going to look at other applications. So see you in the next lesson.